I'm going to try to help everybody with ESC calibration, electrical speed controllers. On the screen, I think this is where we need to start and just understand basically what we're talking about when we say a pulse width modulated signal. There's 3 pulse width modulated signals on this screen. Right here we have 0 volts going through all 3 of the signals. Actually, there's 3 signals per 3 different signal widths here. So you can see that this signal is being measured for inputs every 20 milliseconds. Microseconds. I guess that's microseconds. Anyway, and during this time from here to here, when another signal starts again right here, this is the start of one signal. It ends right here at 0. When this comes back up to 5 volts, this starts the second signal. So they're showing 3 signals here instead of just 1. So it comes up from 0 to 5 volts and it stays here for a particular period of time. And this is the width that they're talking about when they say a pulse width modulated signal. You can see the next signal down is a little wider than the top signal. And the third one on the bottom is still wider than the top signal. Ignore this out here to the right where it's talking about degrees of rotation, because believe me, you don't get that many degrees of rotation in a servo or whatever with such a narrow change in pulse width. They need to all come out here for that much of a change in signal as this. But anyway, this is what we're talking about from 0 through a full cycle. How much of this signal is 5 volts and how much of it is 0 volts? And that changes. And that's a numeric value. The time from this leading edge to this falling edge of this part of the signal has a time period. This gap has a time period. This one's a shorter time period and this one's still a shorter time period. They're labeling these as 1 millisecond, 1.5 and 2 millisecond pulse widths here. It's not exactly how we do it in RC, but this is exactly how all pulse width modified signals work. When we do it for RC, we don't go completely at 0 for the 0 position on a servo. We actually have a little buffer. I'm not going to get deep into the reason for that, but there is some. It has to do with timing, but the rest of the signal we use. So it goes down to about 500. Let's see. There's someplace I saw that information in some of the stuff I have prepared. Yeah, here we go. Right here it talks about the pulse width modulated signal or pulse width modified signal. The width is modified. That gives us information, and you can see right here they say the range is 0 to 9950 microseconds on remote control. Oh, here they say remote control pulse width is generally during, boy, I don't know who translated this from another language, but they messed a little bit there. I find it to be humorous frequently. So let me speak the way that we should. Here, a remote controlled pulse width is generally is from around 1,000 to 2,000, and we see that when we calibrate our radios and stuff in like Ardu Pilot. I've never calibrated a radio yet in iNav, so I can't speak to that yet. Might not have to. Who knows? I see frequently 910s, 965s as a pulse width when I calibrate my radio, and we're going to do that in a second. I don't see it stay as high as 1,000. I have seen some of my calibrations over the last 8 or 9 years at 1910, some of them at 2100. I've had servo stretchers that try to change this number by modifying the pulse width after it comes out of a flight controller before it gets to the peripheral. I've connected to that pulse width stretcher, so I'm stretching my pulse width with that device. That's for advanced. I won't get into that deeper here. I've gotten up above 2,000. Right here is basically what you'll get out of a servo stretcher. They don't really sell them anymore. That's kind of something that's gone the way of the dodo, because frequently now these new OpenTX radios, you can change your signal much more than you used to be able to. So you see, the smallest RC signal we're usually ever going to see is going to be somewhere around 500 or 550. In my humble opinion, and honestly, the largest one I think is going to be 2200. So that's the range of the width of that signal that you're putting out on the RC channels. Now, the way I like to look at this, and this isn't exactly correct, I like to look at it as the servo follows this falling edge. So if this is that 500, the servo's sitting there at 0, and as that edge moves to the right, filling in this time period, and see a 2500 would fill this whole thing in. It wouldn't do it completely, again, because timing constraints, but let's not get that deep into electronics. Just like you have to have some timing on the front, that's why it's not really shorter than 500. It's really not on the other end either. But basically, you could assume that this went fully 5 volts and stayed that way for the full signal. That's when you would get the 180, as far in that direction as the signal could tell it to go. And see, there's 3 things here that are important to us. That's the minimum width that our electronics is going to put out, and our maximum width that our electronics is going to put out. Those are the 2 most important. But the middle position is also important too. You might recognize that as 1500. You might have seen 1500 a lot in your radios and such for your middle position. And to me, that would be like a 90-degree angle on a servo. So down at 500, the servo would be as far left as it could possibly go, and at 1500, the servo would be in the middle, and at 2500, it would be all the way far right as it could possibly turn. All radios, all our electronics put out different numbers for that pulse width. You can get 5 different Radio Master radios out of the box and measure the pulse widths that they put out, and they'll all be different. The circuitry, they don't buy circuit components with a high enough tolerance to be precise. They buy them with enough tolerance to be accurate. You can buy resistors and other components for electronics in several different flavors, and they come in a plus or minus a tolerance of how close they are to what they're supposed to be. You can buy a 100 ohm resistor with a tolerance of 20%. That 100 ohm resistor may actually be 80 ohms or 120 ohms. It can be as much as 20% out of tolerance for what it's marked and manufactured to be. They also sell that same resistor with a tolerance of 10%. Those are a little more expensive for that 100 ohm resistor, and it's guaranteed to be within 90 ohms and 110 ohms. They sell them down to plus or minus 2%. That resistor will be from 98 to 102 ohms when it's marked as 100. Now, everybody's beating on these people for the cheapest price. Why people beat on people for the cheapest price when they want the quality, I have no idea. But they're not going to buy the plus or minus 2% transistors, capacitors, inductors, all the little basic components that make up transistor circuits, etc., etc., etc. They're not going to buy them at plus or minus 2%. There's a massive difference. Only place I ever worked with components plus or minus 2% was the Navy, military. And that's all we worked with. They didn't allow anything but plus or minus 2% components. So if I had a Navy Radio Master, 5 Navy Radio Master radios, and I checked their pulse width, they would be within 2% of each other, not 20. And someplace, see, that gives you a width of 40 that you could be anywhere in that range, that circuit. So it's not going to operate the same as the others. Also, with age, different soldering, how good the solder joints and stuff are, they're going to have even less precision. They're going to be accurate, but they're not going to be precise. It's not going to be the same. Sorry about that. I had to answer my phone real quick. So, because circuits, even the same radio from month to month, it's probably not going to deteriorate over the first few months. You've got it the first year, but the higher quality they are, the more they're going to stay where they were manufactured as far as calibration. We don't recalibrate our RC transmitters. We don't recalibrate our receivers. So this is the pulse width we're talking about, and that pulse width can vary widely. This will affect how far a servo turns, but the biggest thing it's affecting for what we're talking about right now is how many RPMs you're going to get out of your motor on an electrical speed controller that uses a pulse width modulated is actually what it is. Pulse width modulated signal that goes from low RPMs to high RPMs. If it's not calibrated right, I'm going to show you one in a second here, it's not calibrated right, you're not going to get full RPMs out of it, or you're not going to get anything out of it when you first start giving it input. It doesn't know it's low. It doesn't know the bottom number of that pulse width, the 500 we're talking about. Even if it knows the 2200, even if it thinks the 2200 is 2600, it probably will give you full throttle. But if it thinks the top is 1600, it's not going to give you full throttle. Just like if the bottom is 500, you turn it to 501, you're going to get a small RPM. But if the bottom ain't right, you're not going to get anything out of it till you get up to 600 pulse width or 700 pulse width. And that's what we're trying to calibrate when we calibrate ESCs to the pulse width of the device that's giving it the pulse width signal. So, I bought one of these. They're displaying it here upside down, but don't tell them. Yeah, bless their hearts. The text is upside down, the label of the pulse width and the frequency. It'll measure frequency also in addition to the pulse width. And here's your pulse width input, your voltage input, and your ground input. We need to rotate that to have it actually the way it is. But anyway, this, I think I paid $12 for mine. I think I got mine off of Amazon at one time. I couldn't find any on Amazon tonight. But this plugs in ground, voltage, and pulse width modulated signal on this pin. It can be put in line. In other words, you can have your RC receiver, this device, and then a servo connected into the other port on this device, and it's just going to be in the middle reading the pulse width. It's not going to affect the signal. It's just going to pass the signal. I find it very useful. It's going to display the pulse width, and this is where I came over just a second ago and got that information. It's going to display a numeric value, more like this to this, in my humble opinion. Oops, 2500 in my humble opinion, rather than this. It's going to display the numeric value of the current pulse width of your signal. This can be the output signal of your flight controller. This can be the output signal of your RC receiver. This can be the pulse width output of a servo tester like I have on the bench. Before I show you that, there's a plethora of these devices that display the pulse width for you to see with your eyes. You can't see this theoretical electricity 5-volt signal that's changing its duration or its width during that cycle. So we have to have help. You can see here's exactly the one I bought. These don't really look, some of these don't look like what I'm, here's another one. I don't know if that's the same one. There's actually projects, Arduino projects out there that you can make your own pulse width display with Nixie tubes. Here's another one that's different from the one I bought. This one comes from Servo City. So that's showing you a 1704 microsecond wide or duration pulse width modulated signal. 1704. So these, they're cheap. Wow. See, this is the way I do it with an oscilloscope. But you can find them. I'm not sure about Amazon real quick. $2K. I guess that's the frequency. No, they're talking about TVs there. Nah, they're just not gonna. I don't see any as I come through here. There may be. Whatever your favorite vendor is, and I'll put a link to this one, although I guess there are some still for sale. Which what you're looking for there is a Pwm detector, tester, or display. And like I say, there's Arduino projects to take Nixie tubes like this and build your own. They're really quite simple. So, with that said, let's look at some of this real quick down on the table. Okay. This is the device I was just speaking of. The Pwm Detector. It's made by Payne, P-A-Y-N-E. This one's made by Payne. And you can see right here is your PWM signal in. This middle one's 5 volts, and this one is ground. And it will display numbers on these Nixie tubes. That's all there is to it. There's a little switch here to switch from measuring pulse width to measuring the frequency of the overall signal. That's all there is to it. Now this, I've got some servo leads on it just so I can hook it up easily to things without, I hate plugging in these 3 plug dealies. This is a simple servo tester. Whoops. There we go. I don't mind giving ready-made RC a plug. I've been dealing with them almost since the day they started. This is a $12 servo tester. We turn this dial here, we would have that lowest pulse width that we could. If we turn it up, we'll have the highest pulse width we can create. We put it at halfway. We should be in the middle at about 1500, right? That's what a lot of us see, at 1500. This needs a battery input, a voltage input of some kind. Right here you can see input is, what's that say? 4.8, 6 volts for an input voltage. So over here is the outputs. Signal, voltage, and ground. So on my little pulse width display, I want signal, voltage, and ground. I generally leave this plugged into the servo tester. There we go. That's right, it's plugged in. Oops. White, red, and black, bottom to top. That's signal, voltage, and ground. I guess I could have done it this way too. It would have been white, red, black, top to bottom, and signal, voltage, and ground. Anyway. So now, if I just take a little battery, and you get to see some history here. This is a RC Futaba RC receiver battery. This and an RC receiver is what all radio control used to be. There were no LiPos, no flight controllers. We're talking 20, 50 years ago. It was a battery like this and an RC receiver. That was it. And this is where we got our voltage from until it ran down and the plane came home. Let me see if I can get this one plugged in right. There we go. So now I'm going to turn this all the way to the left. And I'm going to try to put my little, need a longer lead, don't I? Oops. I'm going to try to hold it like this. Just a little longer lead. Wouldn't hurt a bit. So right now we can see we have a 981, 82, 81, 82, 81, 82. That's because of drift in this non-precise circuit. It's accurate, but it's not precise. Now as we turn this, the pulse width is going to increase. Well, it's increased to 1,000 now. Ooh, look, I'm coming up on halfway to what? Our normal old 1500, which I can't, neither one of these are precision devices, so I'm not going to be easily able to put it on 1500 exactly. Plus there's some capacitive reactance. Yeah. When you have something near potentiometer. Anyway, 1500 for center, you see. As I turn this up further, I'm generating inside this device a pulse width modulated signal with varying width on the pulse. Now the pulse is 1774 milliseconds in duration or wide. Turn it up. This goes up to 2000-ish. Yeah, 1999.
And as I run it back and forth, you can see it changes. That's the way all of your servos, ESCs, all of the input from flight controller or an RC receiver to whatever device is hooked to it, whether it be servo, whatever. It could be actually it could be a sensor of some kind, but if it uses a pulse width modulated signal, this is how it works. I hope that makes sense. Now, I'm going to take this same setup and I'm going to remove this battery, and I'm going to hook an ESC to it. And I have an ESC here that I'm going to use on the Sky Hunter. Oops. It's a Turnigy, Turnigy Thrust 70 amp ESC with an SBEC built into it, battery elimination circuit. In other words, it can supply voltage for things like that battery was just doing. So I have that hooked to a little motor. These were the original motors for the Honey Badger. Yeah, that's years ago. And then here we have, whoops, that connector was a place where I was tapping off voltage, battery voltage and ground. And you see that comes out to a XT60 connector, which goes down to a battery, and I have a on-off switch in the circuit. So ignore where I tapped off battery voltage here. The other wire out, this is the control wire that expects a PWM on it, pulse width modulated signal, and it's going to vary the RPM of your motor on this ESC based on that pulse width. So I'm going to hook that into this servo tester. Display. That's why I usually leave these socketed connectors attached. Okay, that is, let me just keep it out of the way. That is all connected. So now, because this ESC has a BEC in it, HIJKLMNOP, I hate all this nomenclature, because of the battery elimination circuit in the ESC. When I turn the main battery on for this, this is going to get power. I don't have to have the little RC battery, that right there, hooked to it anymore. I'm going to get power from a different source other than this battery. So let's turn that power switch on. We can see our pulse width display came back up, and we have a pulse width now. This is our lowest possible pulse width, because what's generating our pulse width is all the way on its lowest position. And watch as I turn up this dial, and watch for the motor to come on. Let me see if I can make this a little more. Okay. And then here it comes up. 1,000. Wow. It waited till what? It didn't come off. The motor didn't start turning as soon as my signal started coming up. There, it finally started turning at almost 100. If that inaccuracy was on the other end, I would be losing high RPMs. Right now, I'm kind of losing low RPMs. In other words, my motor isn't turning on as soon as it could. And of course, if I turn this further and the number goes up, you can see the motor turns faster and faster as that number goes up. And as the number decreases, the motor RPM goes down. So that's what we're after. And you can see this ESC is not calibrated correctly. Each ESC has its own calibration method. Let me see if I can calibrate this one. This one's a special one, so I'm just going to play this by ear real quick. Let's, whoops, shaking the camera. I'm going to act like I've turned off my battery, put my transmitter throttle all the way up, and then I turn the battery on. When the ESC signals me that it knows the high number that it's ever going to see out of my electronics, then I will put the pulse width to the lowest number it will ever see out of my particular electronics, and then it should be calibrated. I haven't tried this, but let's see what happens here. Did you hear that signal out of the ESC? And now it gave out another signal when the number was at its lowest. If I turn it back off now, it should be storing those values. When I turn it back on, seeing the throttle isn't as high as it can possibly go, which puts an ESC into programming mode, then it should just basically beep and tell me what cell battery it sees connected to it and that sort of thing. It's a 3S battery, so there should be 3 beeps out of it when I turn it on again. 3 beeps, and then a short single beep telling me it has no braking turned on in this ESC. That's a different subject. What we were interested in now is what happens when I turn this dial now. Look, it isn't much less. Matter of fact, that shows it's not any less. Maybe 20 points less, but this isn't exactly the ESC to illustrate this with. But if we look up this ESC, what we have to do is look up here on the screen real quick.
This is the ESC that's on the table, and you see, like many of my items, it's a discontinued product. It's old. It still works. I'm going to use it on the Sky Hunter. Why should I throw it away? It costs $33. You know what a 70 amp ESC costs nowadays? $80. Why should I throw it away? It's going to spin my motor just as good as any ESC on the planet. I'm not doing it. I'm not going to do it. And so probably I'm going to have trouble calibrating this no matter what I put it into. I'm not going to have trouble because I know how to get around the problems. I'm trying to help you learn to get around the issues that we all seem to be running into. So if you come into the user manual, you have to go to the user manual for every ESC you want to program, because it is the duty of the ESC to get its own, to tell you how it's programmed, what it can be programmed of, and how to do it. I came here to show you why my little calibration demonstration out there wasn't as successful as I wanted it to be. But that's kind of because this ESC doesn't need calibration. It does it automatically. So you don't have anything in here about normal calibration. It just says switch on transmitter and check throttle settings are plus or minus 100%. You got a servo reverse function in this. Well, sometimes you have to reverse the servo. We'll get into that when we see an actual calibration on a flight controller. Okay, yeah. This is just normal startup here, is all it is. Just exactly like it's labeled, huh? Transmitter switch on, battery pack connected to the controller. They're talking about the ESC there. Receiver switched on, or the BC. Then you hear one beep for brake on, 2 tones for brake off. See, that's not quite true. You heard it just now yourself. You actually hear a beep that is equal to the number of cells of the battery that's attached to the ESC. In this case, I had a 3-cell battery, 3S battery connected to it. I got 3 beeps. If you want me to get a 4-cell battery and show you that if I connect a 4-cell battery to it, I will get 4 beeps. I can, but trust me, it will work that way. So see, that's not even in this list, and that's another problem with all this, because see, this instruction sheet isn't completely correct. There's flaws in all of this stuff. And that's why we all get so frustrated. So when your receiver switches on, you will hear a number of beeps equal to the number of cells into the battery that is attached to this ESC should be inserted between these 2 lines right here. And then you will hear 1 beep for brake on and 2 tones for brake off. Well, that's wonderful, because I'm going to have to go back while I'm talking and see if that actually works. You may hear a motor running here real quick. Oh, yes, the brake is on. Boy. And we'll get into that later too. That stops that lets the motor use its own electrical fields to stop itself, which is very important for rear prop airplanes, where you might want to be able to stop the prop with it not perpendicular to the ground. Well, actually, you'd want it perpendicular to the ground so you don't break it when you land. Anyway, the position of full throttle will be calibrated automatically. That's the only place here they're really telling you that this ESC is automatically calibrating. Even though this is a really old ESC, it didn't need calibration back when I first bought it. Your motor is now ready to run. Sure. This is a Simon K ESC. And this Simon K ESC User's Manual in Section 8 will tell you how this ESC wants to be calibrated. Normally, you do not need to do throttle calibration for new multi-copter ESCs. I personally disagree with that. I know a lot of people would disagree with that statement, but you must disagree with it too if you're sitting here wanting to calibrate your ESC. However, in some special cases, you still need to do it. I still do it as part of my initial setup, period, ever. Remove your props, disconnect the battery, push your radio throttle to maximum, connect the flight battery, wait for 3 beeps. They don't know if it's going to be 3 beeps or 4 beeps. Is it a 3-cell or a 4-cell? But at least they're talking about the beeps to signify the number of cells attached in this ESC documentation. D-da-dee, whatever. Wait for 1 second. You will hear a short beep, dit. Then immediately lower the throttle to minimum. You will then hear a unique 2 beeps, dit, whatever, indicating you have now set the low value. If you hear a long beep, it means the low throttle. What the hell? Okay. If you hear a long beep, it means the low throttle is set, I guess. Disconnect the battery, throttle calibration is done. Yeah, here we go with the rest of it. If you hear a short beep, it means the low throttle setup failed. You need to do the calibration again. If still no success, please contact us. Every ESC is going to have a different. Let's look in here real quick. Oh, that's the end of this. Doesn't look like this one is. Actually, this one's doesn't have a lot of programmability. This is an old ESC too. So the point of this is calibration is different for every ESC you touch. The specifics on the ESC that you currently have in your hand will be in the manual for that ESC. You won't find that information in the flight controller manual. You won't find that information in the RC receiver or the RC transmitter manual. You will only find the true information. We've seen little problems with translations. But the truest, you will only find the truest information in the ESC manual for that ESC. And what we're trying to set here, we're trying to tell the ESC what the value is of our highest pulse width. When the pulse width is at its longest duration, and what the pulse width is at the shortest duration. And the midpoint is important to us too, but that's really not calibrated. We calibrate the top and the bottom, and most of the radios assume that 1500 is the center. And I've got radios that put out 910, and I've got radios that put out 965 for the bottom comes to mind to me. It just depends, and it should be just calibrated. So, with that in mind, let's look real quickly at Ardu Pilot.
I'm going to give you a little trivia here for just a second before we do Ardu Pilot. And these are some programming boards from the days before we programmed a ESC with our throttle sticks and stuff. In the old days, we would set jumpers for all the functions. For all the functions that you can change on this ESC. Oh, come on, focus. Focus. Oh, there we go. Oops. You can see this jumper in the upper left was for telling the ESC what battery type you had. In the position it's in, it was for auto detect. If I put it up here, we're telling it specifically it was a nickel metal hydride or a nickel cadmium. Here's your low and high acceleration on that jumper. This one's particularly in low right now. Here's your low voltage protection. Right now it's in reduced power rather than ignore or stop motor. Here's your timing. Here's your rotation, normal or reverse. Here's your switching frequency. What does that say? Looks like 8 or 16 kilohertz. And here, whoa, portal-wise, is something. Oh, that's brake, and it's currently off. So you would put all these jumpers on this board in the positions that you wanted to program the ESC. You would plug the ESC into the right port on this device, and you would plug your RC receiver into the port on the left side that would supply your pulse width. So you could do the high throttle to put your ESC into program mode, and then everything in this card would be programmed into your ESC. This is another card like that for different ESCs. You can see this one goes a little further on the battery, nickel metal hydride, LiPo. Got some other things there. They all have to do with battery. There's your startup, soft. There's your brake on and off. There's your protection type, battery protection, rotation, normal, reverse, timing, different frequencies there. You would plug your ESC in to this and then turn it on, and that programs some ESCs. Here's another older one, same dealie, except this one has push buttons on it, and when you select the particular option, there we go, particular option, you can switch the lights back and forth to turn the brake on and off, tell it what battery type, cut off voltage, cut off type, start mode, timing mode, music, number of LiPo cells, and governor mode on that one. Load defaults buttons down here, program that. So you used to plug your ESC into this to program it. Then when quads first came out and we had to program 4 or more ESCs at the same time, when we first started doing that, we used one of these little boards. This is called an all-in-one board, or a little hub. It just lets you plug 4 ESCs into it and has one input over here for giving it its calibration numbers. I've used 2 of these in parallel to program more than 6 at a time. You can still do them 1 at a time. The pulse width on your radio and your receiver is not going to change. You can take 4 ESCs, program 1 on your receiver, disconnect it, put number 2 on there, program it, disconnect it, put number 3 on there, program it, put number 4 on there, and program it. You're not changing the electronics you're using to produce that pulse width, so what you're using is going to be consistent and the same each time. And you're going to successfully program all 4 of those ESCs with the high throttle pulse width that your radio is going to be forever giving it to it, and for the low. Now we'll take a look at ArduPilot.
Okay, we're in ArduPilot Mission Planner is what it really is. A lot of these terms are just thrown around loosely. In setup, mandatory hardware, radio calibration. If I turn on Calibrate Radio right now, I've got all my stuff saved away, so I don't have to worry about this. It says click OK and move all RC sticks and switches to their extreme position so the red bars hit their limits. This is the radio and the flight controller getting their calibration. You can see I just raised the throttle. You can see right here I've got a pulse width of 2005 here at a high throttle. Now I'm going to lower the throttle and it's 982 at the bottom. That's a little different than that servo tester I had on the bench, isn't it? Yes, it is. Okay, I'm going to do my other sticks. I got a 205 on the roll, 982 at the bottom. On the pitch, when I pull the stick down, it goes up. There it goes up to 2005, 2005. Midpoint is 1470, 982 for the bottom. You don't really see a midpoint on the others because they're not spring. This one is. This is the YA 205. Bottom is 982 again. Wow, my radio's pretty well calibrated. We go through the switches. We have this switch right up here we're looking at right now. We have a bottom of, I think, 982 and a top of, no, it's 205. This next one. This is letting the radio and the flight controller tell each other what the numbers are going to be for my highest and lowest number. Click when done. We're not really talking about radio calibration here, but we're illustrating the lowest pulse width that each of our channels is going to give out and the highest pulse width that each of these 11 channels here gives out. This flight controller stores these away. That way it knows when it sees a 2005 on channel 1, it's being commanded to take the roll as far to the right as possible. If it sees 982, it's going to take the roll as far to the left as possible. And if it sees 1500, it's going to be centered. These just happen to all be the same. I wish they hadn't have been for this because they're frequently not, even on the same radio. But I've just calibrated my radio pretty well. That's a whole different subject. Bang your sticks around on calibration and you won't get a good one. So now we're still talking about pulse width. Let's follow this pulse width to the ESC. Here we're coming in for the gold. Home is in sight. Now right now, with the ESCs I have in this platform, I can click up here and choose an ESC out of this list. And I did this with the flame wheel, which is what's connected to this mission planner right now. And I click Calibrate ESC. That gives the flight controller a signal that you're going to lose power. When you see power again, I want you to pass the throttle signal as it is out. Don't do anything else for that time that your battery is plugged in. When your battery is unplugged, I want you to revert back to your normal operation, and you're not going to be passing the throttle signal straight through to your output. So again, this list right here is in error too. We always remove our props, period. Basically, if it's indoors, the props are on. If it's not being flown, the props are off. If it's indoor, the props are off, not on. Sorry about that. After pushing this button, disconnect both the USB and battery. If you don't power down the flight controller so that it can have that power up, that it knows it's going to pass its throttle signal without modification, you're not going to succeed. So you can disconnect the battery all you want, but if you don't also disconnect the USB and let that thing completely power down, it's not going to happen. A lot of people get in trouble for that. So what's not in here that's very pertinent is you want to make sure before you plug the battery back in that your transmitter is on and your throttle is in the high position. That way, when the flight controller powers back up and is passing the raw signal out to the ESC, it will be giving the ESC that 2005 from right here as the highest number that the ESC will see, and this is when you're supposed to be at your highest RPM. 982 is when you're supposed to be at your lowest. With your throttle high, you plug back in the battery. And the picks hawking stuff, there's a safety switch and some other things and some LED flashing that goes on that you have to wait for, and the little tweedly D's and all that crap. If it's present, that's why I don't use a safety switch. Then it just simply says ESC should beep as they are calibrated. Well, that goes back to the manual on the ESC. We know that the ESC, some of the ESCs, when it sees the throttle high, will give you a couple of beeps to say, okay, I saw the high throttle, now lower your throttle to 0 and let me see the low number. That all takes place in this line. They don't really go through it well here. They do in their documentation. Then you power down your flight controller, and then the next session when your flight controller comes up on battery, it'll come up normally, won't be passing the signal, it'll be acting like a flight controller. That's when this works, and this worked exactly like this. I could have come in here and changed these numbers on my flame wheel. On my mini Talon, God, I guess I should have plugged it in. This box would not come up on the mini Talon. It came up and said, make sure that your ESC is AC 3.3 plus. At this point, I don't know what that is. It's not part of this discussion, but it is the reason that this step fails on my mini Talon. And I think what you're most interested right now is how do we get around that problem? Well, the way I got around that problem on the mini Talon, and I'm going to jump out real quick, shut this down. I'm going to have to throw the Arduplane software onto this flight controller real quick to show you exactly how I did it in the mini Talon. And here's why I think I had this problem. Here's why I think a lot of others are having problems with this. You see, my old ESC actually, well, I didn't do it through the flight controller for the thrust. We will be doing that with the Sky Hunter. But I think those old ESCs just aren't up to date with this software, and it doesn't understand them, so it doesn't even let you have that drop down list to choose from. It won't let you, when you click Calibrate Esc, it just comes up with that error message. That's what was happening to me on the mini Talon. And I personally, people aren't really showing me or telling me what happens to them when they click right here, but I think they get this right here. And see, I just got it on this platform when I didn't get it, and I can no longer click in this box. There's a difference in Arducopter and Arduplane. Right there, I just discovered. Right there is one of the reasons Arduplane people are having trouble when the Arducopter people aren't. See, this is what I got when I did it on the Arduplane with the mini Talon. Set parameter error. Please ensure your version is AC 3.3 plus. Don't really need to look up what this is talking about right now because it's failing. I will look it up before I post this video. But this was what was happening And just to prove it right this second, I'm going to disconnect again. I'm going to go back to an Arducopter flavor of this firmware without unplugging anything, without changing platforms. My fingers will not leave my hands. And you watch, as soon as this firmware comes back up and I connect, it will let me click Calibrate Esc. So I'm sure this is driving other people besides me crazy. And I've gotten help requests from several people. One before I even had my concussion, and I felt so bad that I couldn't help with that one. And then my brain concussion where I fell on the Segway tour just had me really out of it for 3 months. Come on, reconnect. I'm going to have to.
Inactivity alarm.
Yes, I know, radio. Been 10 minutes. This video's getting way too long. People are asking for it. People need it, in my humble opinion. This is a problem. I hated it when I was doing the mini Talon. And I will show you how I got around it on the mini Talon. Okay, I did unplug the USB and I did plug it back in to get a hard reset so I could reconnect to this platform. And right there it is. Let me go in and tell it that this is a D-Shot, it's a brushed ESC, it's a PWM ranged ESC, and I can change all the values here. But it will not let me do it in Arduplane. I will research that further and find out why. Does it like the same hardware in Arducopter, and it doesn't like exactly the same hardware seconds later in Arduplane? There's a logical explanation for it, and I'll try to find it for you. But I'm still going to show you a way to calibrate the ESCs when you run into any situation like this. The only thing the ESC needs is to be put in programming mode on power up, and then be able to see the high throttle and low throttle position. It's the RC receivers and the flight controller that is put in the mix between the RC transmitter and the ESC that's given us all the problems. In this case, it is the H743 wing that's in this Arducopter flame wheel platform in front of me. I've just set it up for Arduplane again. So if I just had a little old RC receiver around here, and I had my little PWM monitor, and I connected my RC radio to it, and I moved my throttle up and down, and I looked at my little PWM monitor, and I saw that my low is giving me 985 and the high on the stick is giving me 2005. I know that I can hook that RC receiver to my ESC without the flight controller in the loop and program a high throttle into that ESC of 2005 and a low throttle of 985 or whatever it is into that ESC, and then take that RC receiver and set it aside and plug that motor back into that flight controller that's going to also give it those same numbers. Now that we know what those numbers are for this particular transmitter, receiver, and flight controller, and they will be different with all those electronics differently mixed, I can program one ESC or 100. Put it on as many flight controllers as I want. It's going to be fine. Now, the way I did, and I don't like to speak a hell of a lot about this, is I came into our do full perimeter list. Here is the arming check. This tells checks prior to arming motor. This is a bit mask that checks English again. This is a bit mask of checks that will be performed before arming. Oh, no, this one. No, this is the one I want. I came in here and told it, well, no, here's where I really want to do it. Arming required? No. I would set both of these to 0. I set this to 0. Crapla. Uncheck this one and do a tab. Is it going to let me? Yeah. Set that to 0. There are no arming checks now. Arming required. I would also set that to 0. No, arming's not going to be required. And then there's an initial mode. Is that where that is? H-I-N-I. Yep, right here. Initial mode. See, this is still setting in it. Initial mode is 0. Manual. In other words, when I power up this platform, there are going to be no arming checks because I set these two perimeters to 0. You have to write them out to the platform. There's no arming checks. I've made sure both places here just to be for sure. It only needs one of them. I think this one. I do both of them. So the flight controllers are going to come up immediately armed without anything else. And it's also going to come up in manual mode where the flight controller is not manual mode right there. The flight controller is not modifying the signals from its inputs. It's just passing all of them to its outputs, and whatever's attached to its outputs, it's happily going along. There's different flavors of this, as we know. On an ESC, it's just either passing or not. On a servo, it might be in stabilized mode. The input signal's modified slightly based on the orientation of the platform. If you're in a guided mode where you've told it that you can't bank more than 45 degrees, it's not going to let you do that. Bank the plane any more than 45 degrees. Your input signal's being modified by the flight controller. In manual mode, nothing is being modified. So in this case, you could power down the batteries after writing these parameters out to the flight controller. You could power down this flight controller, put your RC transmitter throttle to high, plug your battery back into your flight controller. Your flight controller would come up with no arming required and in manual mode, and immediately start passing the throttle signal to the ESC. The ESC would see that it's getting a high throttle number and know that it needs to go into calibration. Based on the programming in the programming manual for the ESC, it will tell you how you need to do the calibration for just straight ESC calibration. You're not wanting to program it for brake or anything. You're wanting to program it for calibration. It'll give you the tones to tell it, I got your high throttle, show me the low throttle now. You drop your low throttle down. It'll say, okay, I got your low throttle now. I'll give you some tones, tell you how many cells is in the battery and what the brake position is on the ESC, and sit there happily. You power down the platform, the flight controller. Your ESC is now calibrated. you won't have any problems. I will kind of proceed to figure out why does the same hardware ESC calibration work in Arducopter and does not work in Arduplane. I'll probably find that in recent versions of Arduplane it's not required anymore. Something like that. I'll have to dig that out of the documentation. I had no idea until this video tonight that there were differences with the same platform and hardware with different firmwares. But I did have my problem exactly like I demonstrated it with the Mini Talon. And this is how I got around it. This is a far out left field way of calibrating an ESC. I don't think you're going to find it in the Ardu pilot manual. If Randy McKay, whoever's the head honcho for this software, talked to me, he'd probably go, son, don't you know that's just so easy here? It's on page 52 in the manual. You don't need to be going through all those backflips.
Inactivity alarm.
And it's 20 minutes on this long video. Nobody's going to watch this. But people have been asking for it. So, myself, I would just have a PWM monitor. I would look in Arduplane, whatever, when I did my mandatory radio calibrations for what my numbers were here, probably when I ran through there and did my, I'm going to mess up some of the numbers here so they don't all come out the same. And probably what wouldn't be a bad idea to do when you're coming to this step and you click done and this comes up with all these high and lowest numbers that you see on the channels, wouldn't be bad just to go into your computer and say, well, let me take a screenshot of that right there. I'm going to take a screenshot right there of that, and I'm going to save those away on my hard drive. Then I'll have a list to look at later. If I have trouble calibrating my ESC, I can find a spare RC receiver in my shop, go straight up with nothing but an RC receiver. If it's a SBEC or a BEC ESC, you're going to have a battery elimination circuit in it. You're not going to need a battery to make all this work. The only thing you're going to have to do is plug that ESC into the RC receiver, and it's going to supply power for it and ground and make it power up as soon as you plug in the battery. In that case, all you have to do is turn on your transmitter, put the throttle to the high, plug in the battery on that ESC. The ESC will power the RC receiver. The RC receiver has no flight controller or anything to modify its pulse width signal out. So it'll show the ESC the high throttle and the low throttle. You can plug it back into any flight controller after that. It's going to match your radio. If you plug your RC in and put it on your PWM monitor, and you see that that RC receiver is putting out a little different max and minimum pulse width than the one that's on the platform you're actually going to use, the RC receiver on that, for some reason, you're going to see those numbers are different in this by using that pulse width monitor and displaying the pulse width. And you're going to say, whoops, that receiver doesn't go all the way to 2005. I'm going to have to see if I can't find another one that goes to 2005. Oops, that RC receiver goes to 2100. That's higher than my 2005 my flight controller is going to put out, or my other receiver is going to put out that's in the flight controller. I would never get there with my RC receiver in the platform, therefore I'll never get the high RPM. I don't want to do that. That's a judgment call you're going to have to do during the fix of the problem. I don't know how to help with all of those as much as other things. So that's how I got around and calibrated my ESC on the mini Talon. That's what's going on in ESC calibration. And sometimes you're going to have to get creative when you're trying to program that high value, whatever it may be, up here. It doesn't display them unless you're calibrating. Don't actually display the number. Now it's 2006. It does 2005. Oh boy, what's the bottom? 983. I think that's the same. How about that? All the rest of them go to 2006. Nope. 983, 2006. Yes, they did. See? But the numbers are close. The numbers aren't off by even 10%. And here we're, again, being accurate. We're close to the right number. We're not precise, hitting that same number every time. We don't have the high precision electronics to do that. I hate that I ramble sometimes. People have been asking me for help on this. I'm doing the best I can. Sometimes I get sidetracked with other things. Just kind of a happy person. I think some things are kind of funny. But I do try to help. And you guys help me by asking questions, help me be better at this for my own hobby purposes. So I thank you for that. And I thank those of you who watch this video for watching it. And I hope the ones that really need it most do watch it and do find clarity now in ESC calibration. It's a very, very muddy subject. I did think that most of this problem was caused by trying to use old ESCs on very new software. That may end up being the problem with Arduino, but we've just seen that Arducopter calibrates this hardware fine. Arduino will not calibrate this same hardware fine. With that, I'm going to leave it with you and say thank you very much. In the comments, if you can't watch this whole video, put I couldn't watch all this shit. I'll try to condense this down or something. My intention is to help. It's a very rough subject. Thank you.